in this part 4 we will study about the next chemical properties of haloalkanes. We already studied the two chemical reactions. First one is laboratory test for haloalkanes and second one is nucleophilic substitution reaction of haloalkanes. In this lesson today we will study about the elimination or dehydrohalogenation reactions of haloalkane. Now we'll see what is the description in this reaction. When haloalkane with at least one beta hydrogen atom means those haloalkanes. Now see, this is the haloalkanes and this is having a one beta hydrogen atom. This is the beta carbon atom and the hydrogen which is attached to the beta carbon atom is a beta hydrogen atom, is boiled with alcoholic solution of potassium hydroxide. This compound is boiled with alcoholic solution of potassium hydroxide. There is an elimination of hydrogen atom from beta carbon atom and halogen atom from alpha carbon atom. As the result, an alkene is formed. Now, during this reaction, alkene will form. Since beta hydrogen atom is involved in elimination, it is called as a beta elimination reaction. This is our haloalkanes, CH3, CH2, Cl. Now this is our functional group. The carbon atom where the halogen is attached, this is our alpha carbon atom. And after the alpha, the next carbon is a beta carbon atom. And the hydrogen which is attached to the carbon atom, beta carbon atom, it is a beta hydrogen atom. Means this is the beta hydrogen atom and this is a functional group which is attached to the alpha carbon atom. So this is the alpha halogen atoms. Now both of them will remove from this product, from this component. Now when this haloalkane is boiled with alcoholic solution of KOH, now we'll see the reaction. This K will combine with that Cl. So there is a formation of KCl in the product. And whatever the OH is left, this will react, combine with that hydrogen and they will form a H2O. Now what is left? CH2 double bond CH2. Now this bond will break, this bond will break. So to manage the valency of carbon, double bond will form between the two carbon atoms. So this is the alkene, KCl and H2O will be the byproduct. Now as this reaction, hydrogen and halogen is removed in this reaction, hence it is known as a dehydrohalogenation reaction. D means removal. Hydrogen is also removed because alpha hydrogen atom is removed, beta hydrogen atom is removed and alpha halogen atom is removed. So dehydrohalogenation reaction. There are two or more non-equivalent hydrogen atoms are present in a halide. Then this reaction gives a mixture of product. Now we'll see, this is the haloalkanes, means alkyl halide. Here two or more non-equivalent hydrogen atoms are present. Two or more non-equivalent. This is alpha carbon atom, this is the beta carbon atom. Here also hydrogen atom is present on beta carbon atom. On right hand side also hydrogen atom present on beta carbon atom. So for our convenience we will label it as this is beta 1 and this is beta 2. Okay. Now see again. If there are two or more non-equivalent hydrogen atoms are present in an alkyl halide, then the reaction gives the mixture of product. If that haloalkanes is boiled with alcoholic solution of KOH, then we will give the mixture of product. A 2-bromobutane on heating with alcoholic KOH gives a mixture of but1-ene and but2-ene. Now this is our compound 2-bromobutane where bromine atom are present in second carbon atom. So this is the name of this compound is 2-bromobutane. If it is boiled with alcoholic KOH and loss of beta 2 hydrogen atom is carried out. Loss of beta 2 means the hydrogen atom which is present on beta 2 carbon atom, it will remove. So what is the product? CH3, CH2 means this hydrogen atom will not remove, this hydrogen atom will remove and this halogen atom will remove in this reaction. So CH3, CH2, CH double bond CH2 because this hydrogen atom is combined with OH and this Br is combined with OH. So K atom. So KBr plus H2O will be the byproduct here and but1-ene because multiple bond, double bond will present on first carbon atom. This is the structure but1-ene will form Now what is the second possibility? We'll see. Now the loss of beta 1 hydrogen atom. This is the beta 1 hydrogen atom. Here there is a possibility that hydrogen which is present on beta carbon can also be removed combined with that OH, and it will remove in the form of H2O, K combined with Br. So we'll see the product CH3CH. Now this hydrogen atom is removed, so this will be as it is. So CH3CH double bond CH2 CH single bond CH3. So this will be the compound. Now multiple bond is present on second carbon atom. So this is the structure of but2ene. Now the percentage of this. 19% of minor product is formed here, and but2ene, that is the secondary multiple bond which is present on second carbon atom. The percentage of this compound is 81%, means it is the major product here. Now the percentage of this compound will formed, means 81%, that is the major product for but2ene, and 19% for minor product, that is for but1ene, is formed according to Sedzif rule. Now we'll see what is the Sedzif rule. Sedzif's rule is that in dehydrohalogenation reaction, this is the dehydrogenation reaction because hydrogen and simultaneously halogen is also removed. So this is the dehydrohalogenation reaction. Now in this reaction, the preferred product is that alkane which has a greater number of alkyl group attached to a doubly bonded carbon atom. Preferred product means percentage of that compound, that product will be a high, means will be a greater in that alkane which has a greater number of alkyl group attached to a doubly bonded carbon atom. Which compound? Now this is also the alkane, this is also the alkane, but the preferred product is that because this is having a higher number of alkyl group which is present to a doubly bonded carbon atom. Now this is the doubly bonded carbon atom. We'll see here CH3 group is attached to that doubly bonded carbon atom. On right hand side also CH3 group is attached to the doubly bonded carbon atom. Means two alkyl group are present on a multiple bonded carbon atom between the attached to the multiple bonded carbon atom. Now alkyl group is that alkyl group which is having a less, one hydrogen atom is less than that of corresponding alkane. So this is the one hydrogen atom is less, that is CH4 ka. We will get here CH3 because one hydrogen atom is removed. Here also we will get the CH3. So these are the alkyl group. Now we'll see about this structure. Now multiple bonded is this one. Now here in this side C2H5, that is one hydrogen atom is less than that of corresponding alkane, that is ethane. So here alkyl group is present on left hand side only. Right hand side there is no any alkyl group is present. So this is a minor product and this is a major product according to Sedzif rule, because Sedzif rule is said that the preferred product is that alkene which has a greater number of alkene. Here two alkyl group are present on multiple bonded, here one alkyl group is present on a multiple bonded, so this is the preferred product. By using Sedzif's rule, the stability order of alkyl substituted alkenes is Cr2 double bond Cr2 which is highly greater than Cr2 double bond CHR which is also greater than Cr2 double bond CH2 also equals to CRH double bond CHR which is greater than CRH double bond CH2. Now next reaction is D, reaction with active metals. Here again, now next reaction D, the reaction with active metals. Alkyl halide reacts with here two types of metal, magnesium and sodium. We'll see one by one that their reactions. First reaction is reaction with magnesium. Alkyl halide reacts with magnesium in presence of dry ether. Here addition reaction is carried out between these two and will get alkyl magnesium halide, and this compound is known as a Grignard's reagent. Now we'll see the description. When alkyl halide is treated with magnesium in dry ether as a solvent, it gives alkyl magnesium halide. This is our alkyl magnesium halide and it is known as a Grignard's reagent. Now Grignard's reagent is a very reactive compound. It reacts with water as well as the compounds containing hydrogen which is attached to electronegative elements. Now see, this is the Grignard's reagent, react with CH3OH, that is methanol. Now we'll see about their reaction. There is a formation of hydrocarbon RH. What is left? Magnesium is a divalent, so one valence is attached with X, that is a halides, and another valence is occupied by OCH3 group. Now next reaction is alkyl magnesium halide, that is a Grignard's reagent. Is react with ammonia, because this compound is also having the hydrogen which is connected to the highly electronegative elements. Here also oxygen is highly electronegative. Here also hydrogen is attached to nitrogen, which is also the highly electronegative. Now Grignard's reagent react with ammonia. Then there is also formation of hydrocarbon and magnesium. One valence is occupied by X and another valence is occupied by NH group. Now the reaction is reaction of alkyl halide with sodium. This reaction is also known as Wood's reaction. It is a named reaction. We will see alkyl halide, two molecules of alkyl halide. This is also RX, this is also RX. So two molecules of alkyl halide reacts with two molecules of sodium in presence of dry ether. Here R is combined with R. So here we are getting the hydrocarbon, and the byproduct is this twice NaX will be the byproduct in this reaction. So this is the hydrocarbon we are getting here. Now this is the general specific. We'll see CH3CH2Br, that is ethyl bromide. Two molecules of ethyl bromide, same alkyl halide we are taken here. CH3CH2Br reacts with two molecules of Na in presence of dry ether. So here also we are getting by the above reaction, according to above reaction, twice NaBr is the byproduct, and CH3CH2 combined with this R CH2CH3. So here we are getting the alkane, but higher alkanes. Now all alkyl halides, the alkyl halides reacts with the metallic sodium in presence of a dry ether. Higher alkanes is formed. This is the higher alkane here we are getting, because whatever the alkyl molecules are there, it has becomes double while getting the product. So which is having a double the number of carbon atom present in alkyl halides. This reaction is called the Wood's reaction. So it is discovered by Woods. So this is the Wood's reaction. An important name reaction also in our syllabus. Now here in above reactions, here we are getting, I am taking the two alkyl halide, but both the alkyl halide is having the same alkyl group. Now suppose if one alkyl halide is having another alkyl group and another alkyl halide is having another alkyl group, means different alkyl halides we are taken in this reaction, then we'll see about that reaction. When the mixture of two different alkyl halides is used, all the three possible alkenes are formed. Now this is methyl bromide, this is ethyl bromide. So we will write this name of this compound also. This is our methyl bromide, and this is also ethyl bromide. When these two alkyl halides react with sodium in presence of dry ether, here we are getting this R combined with itself R, that is, so the molecule is CH3, single bond CH3, ethane compounds we are getting. This R itself is combined with C2H5 again. So CH3, CH2, CH2, CH3. So here we are having a 2 carbon. So in the product, if it is combined with itself, then we are getting the product which is having a 4 carbon atom, and the mixture of these two alkyl group also, CH3 combined with C2H5, that is CH3 combined with CH2, CH3, that is C2H5. So here we are getting the mixture of different alkanes. So first product is ethane, second one is propane, and third one is butane.